Okay, hello everybody. I wanted to include something here today. I'm going to describe it as kind of something interesting. I haven't been able to find if this is actually included in the course or not, but I think it's really important because I see a use for it for the chess problem from week number 2. Okay, so as I say, it might not be part of the actual course, but I think it's really useful that we see it. Okay, all right. So what it is, it's called ASCII data, and from what I understand, a lot of you would have seen the word ASCII already in the INFT 1201 course, the computer hardware course, but chances are it was probably just described as, well, it was something. Okay, and what I want to do here is I want to provide a little bit more context about why it's here and why it's important for programming. All right, so obviously it stands for the American Code, Standard Code for Information Interchange, but what is it? Why is it here? And of course, more importantly, how does it fit in this course? Okay. So here's the problem. I mean, this problem, by the way, existed a very, very long time ago, just when computers first came out. So imagine a situation: you have two computers. One computer wants to send a message to another computer. Okay, and you might say, well, who cares about this? Well, you know what? You've got a mobile phone, and you are obviously sending information from that mobile phone to another computer. So therefore, you do have this problem. All right, so here's the situation. Suppose that computer 1 wants to send a message that simply says the word hello over the computer 2. You think about it as simple as, well, you just type the letters hello and it goes across to the other end, and this other computer can display it on the screen or do whatever. Unfortunately, one thing that you will end up realizing in life is that the only thing you can send from one computer to another is numbers. Okay, in particular, binary numbers, but there's ways how to convert decimal numbers into binary. All right, but in any case, this is the problem. We have a network that only deals with numbers. So the problem becomes is, how do you send over a word like hello if the only thing you can do is to send numbers? Okay, well, the solution is quite simple. You translate the message from characters that you and I can read, like HELLO, and you turn them into numbers. Like, for example, here's a set of numbers: 72, 101, 108, 108, 111. You see, these are just numbers, and we know that we can send just numbers from one computer to the next. And all we need to do is to convert this into a set of numbers, and as long as computer 1 and computer 2 know that the number 72 refers to the letter H, then obviously they'll be able to transmit the messages. Okay, but of course now comes the problem. How do you guarantee that you are in fact using the same numbers? Why did I pick number 72 for an H? Why did I pick a 101 for an E? Why did I pick number 108 for the L's? And obviously you can see I've got 2. And why did I pick a number 111 for the O? Okay, so the reason for this is we need some kind of a standard, and everybody, both computers, need to agree on what the numbers are. One possibility is we could use the number 1 to represent the letter A, number 2 to represent the letter B, number 3 to represent the letter C, number 26 to represent the letter Z. But of course, we need to know if they're uppercase or lowercase. So what I did was I continued on, and I said, well, let's use number 27 for the lowercase a. And guess what? I'd probably use number 28 for the lowercase b. All right, so some people have tried to come up with these concepts a long time ago and said, okay, we need a way, we need to come up with a standard. So what the American Standards Association did was they came up with this mechanism called ASCII. And what they've done here is you can see that every character that's printable, so in other words, the regular letters on the keyboard, the Arabic characters and Chinese characters and so on, this is very, very different. In fact, it's not part of the ASCII standard. You have to use something else called UTF-8. It's not, I'm not even wanting to dive into this. But what this is, for every letter that you can find that shows up on a computer screen or you can type, they each have a number. Okay, and I'm only going to look at the decimal number and take a look at this. You see, the uppercase H happens to be the number 72. The lowercase e in the hello, that was 101. The L was 108, and the O was 111. Now, your question might be, why did they pick these numbers? Well, there was actually a lot of really important properties about why they picked these numbers. I won't bore you with a lot of details, but a couple of really important concepts. Like, first of all, you'll notice that all the letters from A to Z, they appear exactly in order. That's really, really, really important. And the same thing is true with uppercase letters. It appears from A to Z exactly in order. In fact, you can see that 0 through 9, which are the digits, also appear exactly in order. A couple of other interesting things. You'll notice that the value difference between an uppercase A and a lowercase a, well, what that is the number 97. Of course, for this number, where did my cursor go? All right, and 65. The difference between that is exactly 32. So in other words, if you have an 80 and you wanted the lowercase version, all that you do is you add the number 32, and that would give you a lowercase p. All right, so those functions that are built into Python, which are called to upper and to lower, this is actually what they're doing, is they're simply storing, they're taking the number and they're either adding or subtracting 32 to those values. Now, how can we use this for something? Okay, you know what? In the exercise for the chess program, I'm not going to solve the chess program completely. I want you to think about that, but I want to give you kind of an idea about some of the things that somebody would look at and say, hey, here's an interesting idea. You see, we had a location in the chessboard that looked like this. It was like D5. Okay. Now, one thing that I would question about this is, well, you know what? We had a row number. Okay, now how do we get the row number? Well, we can tell that this is row number 5 because it happens to be the second character. Well, here's what I'm going to do. In order to extract the second character, I just have to take location at position 1. But of course, this is the character 5. Okay, now that's very, very important. It's a big difference. What I'm going to do is I'm going to turn it into an integer because I know that I'm looking for this thing. I'm looking for it to be an integer, not the character 5. What do I mean by the character 5? Well, remember back here, the character 5, it has an ASCII value of 53. And what I'm doing is I'm turning this into the actual number 5. Now, this is not particularly exciting, but here we go. We'll print this off. I'll run it first just to show you that, yes, it is in fact showing us number 5. Okay, but I'm more interested in the column. Now, take a look at this. You see the column, I'll abbreviate it as col, this would be location 0. Okay, and what I'm going to do is I'm going to print the column. Here we go, print col. And if I run this program as it is right now, this is the row number, this is the column letter. Well, now imagine the situation where we wanted to not have the column letter, but we want it to have the column number. Okay, well, we already know, for example, that these are the letters. So it's A, B, C, D, E, F, G, and H. You see, if I had to give this a number, I might be willing to call this number 1, 2, 3, 4. I may call this column number 4. Now, the question becomes how can I calculate this? So I could do something like this. I could say if col is equal to A, then I could say that the column number is equal to 1. And I could do another one to say if col is equal to B, okay, etc., etc. I could do it this way, but it sounds like an awful lot of if statements. All right, and no, I'm certainly not going to do that. Instead, here's what I'm going to do. I'm going to have something called the column number. Okay, I'll call it col num. And here's what I want to do. I'm going to show you how to convert a letter into an ASCII value. It's very, very simple. There's a function called ORD. This is an abbreviation for an ordinal value. So what I'm going to do is I'm going to take the column value, which is the letter D, and I'm going to turn it into an ordinal value, and I'm going to show you what happens when I print col num. All right, so remember what I'm going to see here. I'll even remove these. The only thing I'll see is col num. All right, let me run that for a second, and we'll see what we've got. It comes up with the number 68. All right, now come back to here. Okay, we make that a bit bigger. Take a look at this. You see number 68, that happens to be the letter capital D. So in other words, we can use ORD to convert things back to to decimal. All right, so now, of course, that's not what we want. We don't want it as a number 68. What we really want is we want it as the number 4. Well, how do I turn it back to number 4? Well, it turns out it's quite simple. If I simply subtract 64 from this value and run it, you see now it's telling me the column number happens to be 4. And I can pick different things. Like, for example, H, if I run this, take a look what it says. Okay, it comes back and it says 8. And of course, if we count it, it's 1, 2, 3, 4, 5, 6, 7, 8. That's exactly column number 8. Okay, and so this is obviously a very, very useful understanding, or a very useful concept. If we have access to this idea, we can convert letters into numbers. And by the way, when you store this inside the variable called location, really what it's being stored is the ASCII value H, which happens to be, right here, 72 is stored in memory. So we'll write it this way, stored as 72 followed by 5, which is actually 53. And that's the way how a computer stores strings. Okay, that's exactly the way how computers store strings. It's done this way. So something you have to watch out for. You see, if I was to turn this into ORD, I wouldn't get the number 5. I would actually get the number 53 at this point, because that's what the position number, what the character number 5 actually translates to. But what I'm doing when I'm saying int, I'm saying, okay, take the value as we see it, the ASCII value, and convert it into an actual integer so we can do calculations with it. All right, so now how does this apply to the chess program? Well, you see, one thing that I could do with this is I could start to put in questions like this. I could say, if the column number, say, modulo 2 is equal to 0, what this is telling me, it's telling me, is the column an even column? Okay, in other words, is it this one, this one, this one, or this one? Okay, and I can even ask if the row happens to be also even. And I can now make some decisions about what color to set this to, either black or white, based on what should it be if the column is an even number and the row is an even number. So there's kind of my little hint about if you wanted to try solving this. This is one particular technique. This is the way that I look at the problem. Okay, and the whole trick is take the ASCII value and subtract 64. That will give you the actual column number. Now, the whole thing fails miserably. If I use a small letter A, well, then the whole thing ends up messing up. It just doesn't work at all. So in other words, you really do have to make sure, because you see column 33, it doesn't make any sense. You either have to convert this to uppercase, or you have to put some if statements and say, if it isn't between uppercase A through uppercase H, then please stop. Okay, but that is some extra logic. And yes, that is actually part of the exercise. But as I said, I haven't seen any place in the course yet where ASCII values are actually covered. But just in case we don't, at least now you have like one extra little piece of information about what does ASCII mean and how is information stored.